The visible universe, including Earth, the Sun, other stars, and galaxies, is made of protons, neutrons, and electrons bundled together into atoms. Perhaps one of the most surprising discoveries of the 20th century was that this ordinary or baryonic matter, which makes up less than 5% of the mass of the universe. The rest of the universe appears to be made of a mysterious, invisible substance called dark matter and a force that repels gravity known as dark energy. Scientists have not yet observed dark matter directly. It does not interact with baryonic matter and it is completely invisible to light and other forms of electromagnetic radiation, making dark matter impossible to detect with current instruments. But scientists are confident it exists because the gravitational effect it appears to have on galaxies and galaxy clusters. For instance, according to standard physics, stars at the edge of a spinning spiral galaxy should travel much slower than those near the galactic center, where a galaxy's visible matter is concentrated. But observations show that stars orbit at more or less the speed regardless of where they are in the galactic disk. This puzzling result makes sense if one assumes that the boundary stars are feeling the gravitational effect of an unseen mass, dark matter, in a halo around the galaxy. Dark matter could also explain certain optical illusions that astronomers see in the deep universe. For example, pictures of galaxies that include strange rings and arcs of light could be explained if the light from even more distant galaxies is being distorted and magnified by a massive invisible cloud of dark matter in the foreground, a phenomenon known as gravitational lensing. Scientists have a few ideas for it what dark matter might be. One leading hypothesis is that dark matter consists of exotic particles that don't interact with normal matter or light but that still exert a gravitational pull. Several scientific groups, including one at CERN's Large Hadron Collider, are currently working to generate dark matter particles for study in the lab. Other scientists think the effects of dark matter could be explained by fundamentally modifying our theories of gravity. According to such ideas, there are multiple forms of gravity and the large-scale gravity governing the galaxies differs from the gravity to which we are accustomed. Dark energy is even more mysterious and its discovery in the 1990s was a complete shock to scientists. Previously, physicists had assumed that the attractive force of gravity would slow down the expansion of the universe over time. But when two independent teams tried to measure the rate of deceleration, they found that the expansion was actually speeding up. One scientist likened the finding to throwing a set of keys up in the air, expecting them to fall back down only to see them fly straight up forward toward the ceiling. Scientists now think that the accelerated expansion of the universe is driven by a kind of repulsive force generated by quantum fluctuation in otherwise empty space. What's more, the force seems to be growing stronger as the universe expands. For lack of better name, scientists call this mysterious force dark energy. Many scientists have also pointed out that the known properties of dark energy are consistent with a cosmological constant, a mathematical band-aid that Albert Einstein added to his theory of general relativity to make his equations fit with the notion of static universe. According to Einstein, the constant would be a repulsive force that counteracts the gravity, keeping the universe from collapsing in on itself. Einstein later discarded the idea when astronomical observations revealed that the universe was expanding, calling the cosmological constant his biggest blunder. Now that we see the expansion of the universe is accelerating, adding in dark energy as a cosmological constant could neatly explain how space-time is being stretched apart, but That explanation still leaves scientists clueless as to why the strange force exists in the first place.